Hello everybody, welcome to Blue Marble Science. Today we're going to answer Team Oakley's 7 standard questions and maybe ask him a few of our own. We've noticed that before each show Nathan polls all of his experts and asks them a series of fairly simple questions, but none of them are able to come up with an answer to a single one. So we're going to try to help them out with that and maybe give them a few questions of our own. So Gladys, you ready? Big Blue, how about you? Attaboy. Let's light this dumpster fire and have some fun.
Right, let's do a bit of housekeeping then. Any signs of Earth curvature?
Well, there's this. And things like this continue to happen. Notice anything missing on the left? That's Tampa Bay, and the building with the red roof is between the camera and the city. That's why you see it in this view, but you don't see it in this view. How about this from 100,000 feet? See the pretty curve? But I think I like this one the best.
What about axial rotation? Any signs of that?
Well, there's a whole bunch of these things. And there are even more of these things. And then this happens. Or you could just ask Bob Nodell about one of these things. I think he has some experience with it.
Any scientific evidence of gravity?
Maybe you can tell me what's going on here. See the star in the middle of the screen? Well, it should be over there where the red circle is. Only gravity bent the light. Or maybe you could just watch Jupiter's moons, but I think my favorite really is this.
This is called gravity.
What about the distance to the sun?
Well, yeah, there is. Since we can measure the distance to Venus with radar, the rest of it becomes just simple math. Oh, I'm sorry, I forgot. Let me see if I can redo this in crayon for you.
What about any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
How about taking a wild guess at what makes one of these things work? And where would you think this stuff might be coming from?
What about evidence that we can have a gas pressure without a container for all the heliocentric idiots that believe there is a vacuum next to the gas pressure we all breathe?
Heliocentric idiots, you've got such a way with words, Nathan. So you want to see gas pressure without a container? There you go. And it's so simple, even a flat earther could do it. Well, some flat earthers could do it. Oh, come on. There's got to be at least one of you guys that could do this.
Last but not least, any evidence of the R value? Earth radius.
Actually, we did that too several weeks ago at the Equinox. We did it at 2 different locations using 3 different arrangements, the most accurate of which was a 73-inch high pole, which would have somewhat simulated what Eratosthenes did. The results gave us an error of about 0.1%. Now, there are more accurate methods of doing this, but this worked out pretty well. And the geometry is a very simple thing to do. And in fact, you don't even have to use trigonometry to do this. It can be done another way, and that was shown in this video, which I'll leave a link to, by the way, in the comments. But it produced another interesting thing. When we evaluate the apparent elevation of the sun using the 2 measured sun angles, it shows the sun would have to have been at 2 different elevations. That's totally impossible. But on a globe, it works perfectly. Now, I hope that answers your question. Has anybody else got anything? No, Gertrude, you're not related to Nathan. Big Blue just made that up. Now that we've answered your questions, Nathan, maybe you can answer a few of ours. How about explaining how density causes acceleration? How does density impart a force that would cause objects to fall down? Second question. Can you explain to us what holds your sun and moon in the sky when everything else falls to Earth? I assume it's not that piece of coat hanger you use in your model. So what holds them up there? Third question. Can you explain the atmospheric pressure gradient without gravity? Because without some force holding the atmosphere to the Earth, the atmosphere would have to violate the second law of thermodynamics. Fourth question. Can you explain why the angular size of the sun doesn't change throughout the day? It should be more than a factor of 2 larger at noon than it is at either sunrise or sunset. I mean, it should be very, very obvious, yet it's the same size. Explain that on a flat Earth, please. Here's an easy one. Tell us what causes tropical storms to rotate in opposite directions above and below the equator. What makes them do that? They always do that. There are no exceptions. Tell us why that happens. Now, you'll have to think about this one a little bit. Using the Rayleigh criterion, show us how the bottom of a distant object can disappear while the top of that same object is still clearly visible. Again, how can that possibly work? You need to show it to us. Show us some math that proves it. And finally, this one's just for fun. Where are those boats that patrol the Antarctic? Where do they keep them? Who mans them? Where do the crews live? All that sort of stuff. Now, these shouldn't be that hard for you. Unless what you've been telling us smells a little bit like that. So, hey, thanks, guys. Appreciate you watching. Don't forget to like and subscribe, and we'll see you on the next one.